All right. So, yeah, we'll start with 7A. We'll talk about 7A, and then we'll start with 7B. Now, 7B, there's three parts to it. Today, I think we'll do B1, B2. So, 7A, let's just have a look at our notes book. And we're just talking about the distinction between periodic and non-periodic behaviour. So a function is periodic if it repeats itself in a horizontal direction. So that means as we go across, all right, as we move to the left, it's copying itself, it's repeating itself over and over and over again. And so if we look at the bottom function, that is periodic because it keeps repeating itself. It has the same y values over a horizontal direction. Whereas the top function is not periodic. Even though it's following some pattern, it doesn't maintain the same y values. Okay, so let's open our textbook, let's flick to 7A, and there's a number of graphs there for us to just chat about, and we'll just decide whether we think they're periodic or not. Okay, so it's going to be periodic if it repeats itself. So 7A is on page 171. That's where I'd like us to look. All right. So if we look through, Charles, what do you reckon with A? Is it repeating itself in the horizontal direction? Yep, so this is periodic. Will be?
Yeah, it is.
Good. Noah, C?
Yes.
Yes, it is. It does repeat itself in the horizontal direction. How about D, Bailey? This one's tricky. Do the y values stay the same? No, the y values are changing. It keeps moving up, doesn't it? So this one is not periodic because it's not maintaining the same y values. All right, E, Austin?
Yes.
Yep, F, right, Kira?
Yes.
Good, yep. G, Stella?
No.
No, because the y values are changing. And then H, Rain?
No.
No, because the y values are changing. Very good. Okay, so we're recognising periodic behaviour. Excellent. Let's move on to 7B.1. And what we're doing here is we're going to talk about how we graph the sine function. So first I think I might talk about where it comes from. And if you just turn the page from 7B, you've got a graph there. All right? And we're going to fill this in really quickly. All right? We're going to fill this in really quickly. We will we'll just fill in a few of the values. All right? So I'm going to have here theta and then the value of sine theta. And we can get this from our calculator or from the unit circle. Remember, what is sine theta? All right, but the y value on the unit circle. All right, so we'll start with angle 0. When the angle is 0, here we are in the unit circle, the y value is 0. So sine of 0 equals 0. That's our first point. All right, and then if you want, you can go 1. You know the number 1, so we can go sine of 1, and we set it in radians in our calculator. In radians because we've got pi along there, so in radians. Sine of 1, we've got 0.84. All right, and then we've got sine of pi on 2. Now, if you put in your calculator pi divided by 2, that's 3.14. Remember, pi is a number divided by 2. It's about 1.57 approximately, right? So if we go sine of pi on 2, that's going to be 1. And then what number do I have next? 2. All right, we're just going to do a few of them. So I've got 2, and I'll go, all right, how about sine of 2? So in my calculator, I'm just typing in sine 2. I've got 0.909. And then sine of 3 is 0.14. And then sine of pi, and remember pi is 3.14, right? So pi is 3.14, sine of pi is 0. All right, so you can keep going with this, okay? You can keep filling in the table. But here's what we're generating, is we're generating a graph where on the x-axis we have the value of theta, and on the y-axis, we have the value of sine theta. All right? So this is sine theta, and this is theta. Now, our first point is when the angle is 0, the value of sine theta is 0. So that's going to be there. We'll draw a big dot there. All right? And if we're going off our graph here, I've even given you the constraints. We've got 1 to -1. All right, and so then let's just say you're moving along here. You've got 1, 1.57, 2, I'm just plugging them in, 3, here's pi, all right, roughly, 3.14. And so we're just doing the coordinates, right? When the theta value is 1, so here, the sine theta value is 0.84. When the theta value is pi on 2, or 1.57, sine of theta is 1. When the theta value is 2, the sine value is 0.909, so that's going to be like up here somewhere. When the theta value is 3, we have 0.14 and 0. Okay, so the point of this is to say you can keep going, but what we have here is a periodic function. If I start drawing my curve through it, this is what it's going to look like, right? And if we keep going, we can anticipate, we've just done half a revolution, so here we have positive y values going around, and then we have these negative y values, all right? So then the sine, then it's going to come down here, it's going to come back up, and it's going to repeat itself, okay? What? We have negative y values, and then we get to here, and then if we just keep going around the unit circle, if our angle gets larger and larger, this is just going to keep going in that direction forever. We have a periodic function. So I'll leave that for you to fill in, but this is the basis for exercise 7B. We're going to take this function, y equals sine of theta, and manipulate it. Okay? All right, everyone okay with that so far? All right, so I'm just making a link there between the unit circle and the graph. Now, I might just say one thing here that I think is important. So here, we've graphed the function y equals sine theta, where I've got theta on the x-axis, right? Now, it can be a little bit confusing, but we could also graph the function y equals sine of x, all right? And all we're doing there is using x instead of theta as the variable, all right? Where x is the size of the angle. And we do that because if we're drawing a graph, we have some relationship between y and some relationship between x, right? So this and this mean the same thing, okay? Y equals sine of x. You'll start to see a bit more now. That's going to become common. But still remember, sine is the y value, cos is the x value on the unit circle. All right, so let's take that and let's see if we can solve some of these problems with the graphs. So we have, back to 7b, the general sine function. And we introduce you to some notation here. Who's doing physics, by the way? You've seen these waves before, all right? So we've got peaks and troughs, maximums and minimums, wavelengths. All right. So for the distance for one whole peak and one whole trough, that's what we call one wavelength. All right, and in physics we use the symbol, the Greek letter lambda. All right, so that's one wavelength. It's also the distance from a peak to a peak, okay? So that's half a peak plus a trough plus half a peak. That would be one wavelength as well, right? And so one wavelength is how long is it, and then it's going to repeat itself again. That's what we mean by a wavelength. We also use the word period. All right, how far is it before it repeats itself again? And then we've got principal axes. Here I've got some calculator instructions. So if we're graphing on the calculator, we need to make sure we've got it set in degrees or radians. In the majority of the circumstances, it's going to be in radians. We've got our textbooks open, so let's just flip over to 7B.1 on page 176. All right, and I just want to show you there It says without using technology, we're going to use our calculators, but it says graph the following for 0 is less than or equal to x is less than or equal to 2 pi. So that tells us we're using radians, our angle should be set in radians, and it's given us a domain for which to restrict the function over. Okay, and then if we have the function of this form, a sine b of x, all right, the amplitude is a, all right, and the amplitude is this distance here, right? It's the distance from the principal axis to a peak or the principal axis to a trough, all right? So if I graph the function y equals sine of x, all right, from 0 to 2 pi, here's 2 pi, this is what it looks like. Who can tell me what's the amplitude of this function? What's the distance from the principal axis to a peak? It's 1, isn't it? How can we confirm that? What's the number out the front here? 1, very good. If we were to sketch the function 2 sine x, what's it doing? It's doubling every y value, isn't it? It's multiplied by 2. So it's going to take this one and double it. It's going to take this one and double it. So it's just going to stretch it. It's going to produce that vertical dilation. Okay, so that's the sine x function. The other thing to ask you is, how about, all right, I'm going to sketch it a few times. It's just going to keep going. All right, so that's 2 pi, here would be 4 pi, you know, and you can go in, okay, that's pi, that's 3 pi, that's 5 pi, you can break it up. What is the wavelength? What is the period of this function? 2 pi. It's 2 pi for one whole wavelength. That's how far it is. All right? Here's another way we can check. The wavelength equals, from our wavelength formula, wavelength or the period, we use both words. The wavelength or period is equal to 2 pi divided by b. Okay, b. What is b? b is the number in front of x. All right, so we look down here at our function. What is the number in front of x? 1. All right, 1. The number in front of x is 1. So for this circumstance, it'd be 2 pi on 1. The wavelength is 2 pi. So we can get it from looking at it, right? We can see, yep, wavelength is 2 pi and amplitude is 1. Or we can get it from the description of the function. Amplitude 1, period, 2 pi divided by that number. What's that number? 1. 2 pi divided by 1 is 2 pi. Okay, so let's answer those questions at the bottom using this formula here. All right. Calculate the wavelength of the following. So firstly, we have sine of 2x. All right, sine of 2x. So to calculate the wavelength, we can use the simple lambda if you like. The wavelength is 2 pi divided by b. So in this circumstance, it's going to be 2 pi divided by 2. All right, and this will simplify to pi. All right, so for part A, the wavelength is pi. All right, on to B. We have the function sine of 3x. Let's calculate the wavelength. The wavelength is going to be 2 pi divided by 3. We can't simplify that any more than it is, so we'll leave it like that. Okay, on to C. We have the function sine of half x. All right, so the wavelength is going to be 2 pi divided by half. All right, 2 pi divided by half. All right, so that's, remember how we described it previously? It's 2 pi on 1. All right, that's what's at the top, divided by half. And then we have AD, so we'll have 2 pi times 2, 4 pi on BC. 4 pi on 1 is 4 pi. All right, And you can, look, it's important to know this, but you can just put that in your calculator. You're just going to make sure it's 2 pi divided by, and then that's the fraction. Denominator is 100. All right, so that's C onto D. All right, for D we have sine of x on 5. Now whenever you have something written like this, okay, x divided by 5, it means the same as 1 on 5 times x. And we always want you to view it like this, okay? This is like a little bit cheeky. They're just checking to make sure you understand this and this mean the same thing. All right? That dividing by 5 is the same as multiplying by 1 on 5, right? And so now the B value is very apparent. What is it? What is the wavelength? 2 pi divided by 1 on 5. All right. Well, 2 pi at the top is 2 pi on top of 1. And at the bottom, 1 on 5. And then A times D, 2 pi times 5 is 10 pi. On top of 1, 10 pi. All right, so this has a large wavelength of 10 pi. And then for E, sine of pi x. All right, so sine of pi x. So we're going to do 2 pi divided by pi. All right, the number in front of x is pi. We have pi at the top, pi at the bottom. They will cancel. Our wavelength is 2. All right, so that's what you're doing in B1 is you're calculating the period, but it also wants us to sketch a few graphs. So let's, I've got some instructions there on how to sketch the graphs, but maybe we'll just talk about a few of the ones from our book together. So it says in the book, it says don't use the calculator. I want you to use the calculator, all right? In the test, you'll have access to your calculator. But let's talk about AC, question 1AC, all right? So firstly, it says graph from 0 to 2 pi. So what that means is we need to make sure our calculator is set in radians, okay? And the other thing it wants us to do is restrict our domain. It wants our x min to be 0 and our x max to be 2 pi. All right, so we're restricting x, so we've got it set in radians. We restrict our domain, all right? And then you might go, what do I restrict my y values as? Well, let's look at the first function. It's y equals 3 sine x. What's the amplitude of this function? 3. That means it's going up 3 and down 3. So we can have our y max as 3 and our y min as negative 3. All right? So that would be the case with A. Yeah. That's going to help you sketch it. All right. So I reckon let's have a go at exercise 7B.1 and using our calculator to support us in graphing and finding the period of these functions. All right, 7B.1.